All right, these are the notes for Are You Able with the Table. We're moving into discussing the exponential function. We've been talking about exponent laws, and now we're going to talk about the exponential function a little bit. This is the basic form of the exponential function, y equals a times b to the x power, where both a and b are constants or some sort of number. We want to figure out what effect a and b have on the tables. So if you look at number 1, they first ask me what my a value is, and according to this function, a is 3. My b value is 2. I'm going to plug that into my calculator. I'm just going to go to my y equals menu, and I'm going to plug in 3 times 2 and raise that to the x power. So if you're not familiar with how to do that, you're going to use your exponent key, which is down here under clear, and that will move that up to an exponent, and you put your x in. Now I'm going to my table, and there are my numbers, 3, 6, 12, 24, 48. So 3, 6, 12, 24, and 48. Now it has this extra little column here. It's asking me what my ratio is. We've done linear problems where you move down the table by adding or subtracting, but in this case I moved down my table by multiplying, and that's what they mean by ratio. This time I'm multiplying by 2 in order to move down the table. So now we're going to just reverse those numbers. Now my a value is 2, my b value is 3. I'm going to plug that into my calculator. Now you might be thinking that they're going to come up with the same table, but this comes up 2, 6, 18, 54, and 162. So it is not the same table. So this time my ratio, I'm going from 2 to 3 and 3 to 18, and that looks like multiplying by 3. The reason that they're not the same is because in this case, exponents have to take place before multiplication, according to Please Excuse My Dear Aunt Sally. So instead of multiplying 2 times 3 and getting 6 to the x power on both of these, I have to take care of the exponent first. That's why they're not the same. All right, so the next one, they're asking me what my a value is and what my b value is. There doesn't appear to be an a value, but there is. There's an understood 1, and b is 6. So again, you're going to plug that in your calculator, and you're going to get your table, and your ratio this time looks like I'm multiplying by 6. Problem 4. My a value is 8, my b value is 0.5. Plug that in your calculator. Now this one looks different. This is the first one we've had where the y values are getting smaller each time. It's descending. And it looks like immediately my head thinks, oh, well here, 8 to 4, 4 to 2, looks like I'm dividing by 2. But when they say ratio, that means multiply. So instead of saying divide by 2, I'm going to say multiply by half or multiply by 0.5. You guys know I prefer fractions, but they used a 0.5 in the original problem. So I'm going to use a 0.5. And I think you're probably starting to see the pattern at this point. Fill in my a and b, plug it in your calculator, this time my ratio is 0.5. And last one on the front page, my a is 200, b is 0.8. Now I hope you've recognized where the ratio comes from so that you know that it's just times 0.8 each time. All right, so the question asks, where in the table does the a value show up? Well, in problem 2, my a value is 2, and here it is in the table. Problem 4, my a value is 8, and here it is in the table. Notice what it's with 0. So where x is 0 is where it shows up, or what we call the y-intercept. My A value is my y-intercept. And what effect does the B value have on the table? Well, that's what you multiply by. So it changes the y column. We're going to solidify that a little on the back side with some notes. Now, most of these problems, these exponential problems, are going to be used for word problems. So not only is that A the y-intercept, but we call that the initial value. Because we're going to use this for financial problems, where your initial value might be how much money you deposit. We can use it as the initial value. We'll use these problems in science for exponential growth or decay. So your initial value might be how many cells you have in your Petri dish, and then you're going to calculate how many have died off. Your B value is what we call your common ratio. We figured from the first page that your y value increases when b is greater than 1, and your y value decreases when b is between 0 and 1. So now you're going to do the reverse. Based on the table, you're going to calculate what your function will look like. I can start right off. My initial value is 0, 5. So that's my A, 5. And my ratio is changing. Looks like it's multiplying by 4. So that's my B value. So I can just plug those in, 5 and 4. So that's the basics for Are You Able with a Table. You should be able to complete 8, 9, and 10, and also do the think about it. Plug those in your calculator and see what you think.